SwayamPrabha. Digital India. Educated India.
Hello everyone. Now we will start a new module that is textile for protection from UV rays, and this is extremely important for the people who are always at the outside under sun, or they are exposed in various UV sources. Okay. Now, we will try to discuss the basics of UV rays, what are the different types of UV rays, and how the textile material can protect the human being from all these sources of UV. Now, why are we talking about the UV? So, the basic problem of UV is that it has a great impact on human health, and textile is a material which we are wearing, we are clothing. So, if we incorporate some UV protective performance in the textile material, then we may be protected from different types of health hazards. So, critical health related issues are that we can see that the UV radiation exposure causes 90% of non-melanoma skin cancers. So, you can see here 90% of the skin cancer it is caused by UV ray, and not necessarily all the UV rays are dangerous. So, that affect, but there are particular type of UV ray that we will discuss with the time, and also it affects accelerated aging. So, photo aging is there. So, that skin type will be changed, the skin tanning will change. Okay. So, that these are the critical health hazard, and here we will see the textile as a it can serve as a first line of defense. And the problem here is that we are wearing always a textile material. So, if we can incorporate the UV resistance within the textile, if we, by structural manipulation, by yarn engineering, fabric engineering, by proper coating, then we can protect ourselves from all these hazards. Okay. And in sun protection, so from the sun, for sun protection we can also use the sun protective lotions or creams, but the problem there is that it can get washed away, or it is removed. So, textile is that first line of defense. Okay. We can defend ourselves from all this, we can protect ourselves all this from all the UV related issues. So, engineering UV protected fabrics is extremely important, and by proper engineering we can block up to 98% harmful radiation. So, if we can block 98% harmful radiation with UPF 50 and above, by proper fiber engineering and optimum selection of fiber, optimum selection of fiber density, yarn density, yarn structure, weave structure and chemical treatment. So, by all this textile engineering we can provide UV protection from the exposure. And let us see what are the different types of UV sources in our daily uses from morning to night. What are the UV related actually exposure we are having. So, first is major UV related issues is that it is a solar radiation. It is primarily natural source and directly it comes from the sun, and its intensity varies with the time. So, in the early morning, at the day, noon time or afternoon. So, with the time its intensity or severity varies. Latitude, the location in the earth, the in which location we are having. So, that depending on that the UV radiation, solar radiation intensity changes. Even altitude with the increase in height from the sea level. So, as we go above the sea level, the intensity of the solar radiation increases. And atmospheric condition, it depends on the type of cloud present. Okay. If it is cloudy, then solar radiation reaching towards our to earth will be reduced, and also moisture content, this all these factors affect the solar radiation. Next source is the industrial sources. So, there will be different industrial activity like welding arc. So, when during welding the what is arc generated, that is a huge source of UV ray. So, we must protect ourselves with different types of gadgets, like we have to sunglass goggles we have to use, we may use, or some protective shield, and textile is also one of them. And if the worker is exposed throughout the major time of the day during his work, so that will affect the human health. Then mercury vapor lamps. So, mercury vapor lamp is a good source of UV ray. So, with that we should protect ourselves. People working in with the in that environment should be protected. So, specialized curing equipment where UV is used, UV rays are used. So, in those applications, in those manufacturing processes, so UV ray is generated, we should protect ourselves. So, after industrial sources, next is the artificial UV. Okay. So, tanning bed, okay, photography device, okay, germicidal lamps, black lights. So, all this they are the good source of UV. So, artificial UV we get from all these things. So, we should protect ourselves, and also the from sun direct we are getting UV, but sometime and most of the time we get the reflective UV. So, we may find that we may feel that we are not directly under sun. So, we are protected, which is wrong. Like in hilly area where we have snow covered mountains are there and suppose a person is under the shade, not directly under the sun, but from sun the UV ray gets reflected. So, snow reflects the UV ray very good, at least 80% UV ray is reflected by the snow, and from sand it is 15% reflection, and water it reflects 10% of UV radiation. So, that we can see that in from near the desert or near sea beach, at the mountain, everywhere we get all this reflected solar ray, reflected UV. So, which actually poses danger to human health. So, in those location, suppose we are thinking that we are under the shadow, okay, but still we get lots of UV ray, particularly in snow area, in high altitude, there the problem of UV ray is very high because of multiple factor. At high altitude, as we have discussed earlier, at high altitude the UV intensity is very high and also direct intensity is high. Even in addition to that, we get additional reflective UV. So, that in the hilly area with the snow, the chances of UV radiation we are receiving will be much higher. Now, let us try to understand the UV spectrum. So, different types of UV rays are there. It can be divided broadly into UVA with the wavelength 315 to 400 nanometer. So, that is the wavelength, and 95% of UV, it consists of UVA. So, you can see that we are UVA, UVB, UVC, all these types of classifications are there. Here majority of the UV is UVA, and it is long wavelength, it penetrates deep into the dermis in the skin and cause premature aging, okay, and indirect DNA damage. So, it is a long wavelength, it penetrates inside the skin and causing the tanning, premature aging and indirect DNA damage. Through oxidative stress. So, here this happens, the indirect DNA damage, it happens through the oxidative stress. So, and here the intensity, it is throughout the year, it is constant, okay, constant intensity it comes. UVB, the wavelength is little bit shorter, and we can see the whichever it is reaching in the earth. So, 5% only it consists of UVB. So, majority of the UVB is absorbed by the ozone layer. So, and this is UVB is absorbed by epidermis in the skin and directly damages DNA, causing sunburn and mutation. So, this directly we get sunburn, although the quantity is 5%, but it is damaging, and this is primary carcinogenic wavelength, and it causes the skin cancer, okay. And it varies with the season, whereas UVA irrespective of the season, its intensity is constant UV, and with the season it varies, and UVC, it is basically wavelength is very small, 100 to 400 100 to 280 nanometer. In that range UV C is there, and fortunately it is a high energy content, but it's fortunately it is filtered by ozone. So, it is completely filtered by ozone layer in the atmosphere. So, completely absorbed by stratospheric ozone and oxygen. So, that is good, otherwise it is very dangerous. Okay. The germicidal properties are used in sterilization application. So, that UVC is we can use, we can generate UVC, and that is for sterilization application we use, but if it is exposed to the human body, that will be that will cause great harm. Now, try to understand the UV index. UV index is actually the parameter which will give us the idea the intensity of ultraviolet ray in a particular place, particular location. So, UV index changes with the time or changes with the location. So, that is we must understand how, what is UV index. It is a scale. So, you can see it is a standardized measurement of intensity of UV in a particular environment. So, this UV index, which is it quantifies erythermally weighted solar UV radiation at earth's surface in a particular position. So, UV index is different for at different places, and it is developed by WHO and WMO, and it ranges from 0 to 11, more than 11 also. So, 0 means there is no UV ray in that zone, and 11 means very high, and more than 11 is extremely high. And it is critical for determining the UPF requirement. So, we must know. So, a person, suppose I am going to a certain place, I must know what is the UV index in that location. So, accordingly I will wear the particular cloth to protect ourselves. So, it is textile materials ultraviolet protection factor. It actually it determines the selection, what type of UPF we need, that it is dependent on the UV index of that particular place. And you can see here the 0 to 2, where we do not need that much protection, minimal protection is required, okay. Around 33% is there, and moderate 3 to 5 is moderate. So, standard sun protection will help, and very high, that is chances of our body gets affected is 75%. That is enhanced protection is required. So, we should at low level typically 33% chances of body get affected. So, minimum protection is needed. Similarly, for 6 to 7 level it is enhanced protection required. So, we need certain protective layer, and very high 8 to 10. So, extra precaution is essential. We need very special protection, protective clothing with high UPF value and extremely high, so more than 11 is extreme condition, and where maximum protection is critical. So, we must design our clothing to protect ourselves at different level of UV index. So, we can calculate UV index, or we can calculate our the impact on our body, or that by weighted mean. So, that we will discuss later, how to calculate the UV index of in a particular place, we will discuss later. Now, how this UV exposure affect our body. So, the biological impact of UV exposure. So, it is a carcinogenic in nature, carcinogenic which basically affect causes skin cancer, and it is skin cancer risk increases by 75%, okay, with severe sunburn. Photoaging is there if it is exposed, our body is exposed to the UV for long time. So, wrinkle formation will be there, and irregular pigmentation. So, dots will come, photoaging will take place, and ocular damage. So, corneal damage. So, that the from acute overexposure. So, for acute exposure with high UV index, if we do not use any sun protection or eye protection mechanism like your sunglass or something, if we do not use, so it may damage our cornea. And immunosuppression. So, that is it increased infection susceptibility. So, it with the UV exposure, so that will the different types of infection we can generate, that is it will suppress the immune power of our body. So, these are the different dangerous effect of on our body. So, we must protect ourselves through various ways from the UV exposure. Now, what are the global UV exposure trends and the risk factors? Let us try to understand this. Now, you can see in Ecuador area, the chances, the factor trend is UV exposure trend is maximum. In equatorial area, if we it is a very high area, and subtropical area it is a little bit lower, and in mid latitude it is further lower, and the high latitude, and in polar region its least exposure is there. So, that way we can see the effect of UV exposure, and accordingly we can design our clothing or protection. We can protect ourselves if we know the global UV exposure. Now, these exposures are actually amplified. This can be amplified by various reasons, like UV exposure will increase by depletion of ozone layer. So, that is if ozone hole is created, then that UVB actually can penetrate or UVC can penetrate easily. So, 1% decrease in ozone increase in ozone depletion, that means decrease in ozone layer by 1%. So, that will affect the increase in UVB exposure by 2%. So, which will be very harmful for our body. Similarly, altitude, as I have mentioned. So, in altitude, so 10 to 12% increase per 1000 meter, 1 kilometer elevation. So, for per 1 kilometer we can see, if we go by up above 1000 meter from the sea level. So, UV intensity or it is increased by 10%, 10 to 12%, which will be very harmful for our body. So, the level of protection will be more at high altitude. And cloud cover, so thin cloud transmits 80% of UV. That means, whatever UV was supposed to come now in clear condition, clear sky, 80% will be transmitted, 20% will be blocked by the thin cloud, and if the cloud is thick, it will block more. Surface albedo, what is that? Reflection multiple exposure. So, that means there will be different surfaces, like I have already mentioned that your snow covered mountain, from sand, from water, or from different reflective surface. So, this multiple reflection exposure will enhance the or amplify the UV exposure. And climate changes, shifting the exposure pattern. So, with the climate change, the exposure pattern will increase and which will in fact amplify the UV exposure. So, drivers behind UV protection, protective textile development, what are the different drivers behind the UV protective textiles? So, which actually initiates the development, which is the why textile protective textiles for UV is important. So, one is the public health mandate. So, gradually we have seen that skin cancer, chances of skin cancer or occurrence of skin cancer has increased these days, typically 5% annual increase, gradually skin cancer increase, that is actually due to the UV ray, and which drives the regulatory requirement for occupational and recreational protective wear. So, in occupational, like a person like traffic police, if he or she is standing in the outside environment, or maybe for the agricultural workers, farmers, they are always under the sun. So, for that there will be regulation, and where one must wear the protective textile and UV protection, some level of UV protection factor should be there. And in case of recreation, so there also we have to use certain standard protective textile. Then market demand, you can see that world market demand is actually $1.2 billion global sun protective clothing market. So, it is a huge market is and it is increasing consistently. Consumers seek scientifically validated protection with comfort and aesthetics. So, that is there. So, we need protective textile which will prevent the UV ray directly coming to our body, and at the same time the aesthetics will be there. It should look nice and comfortable. So, moisture vapor or thermal transmission, air transmission should be there. So, all these requirements are there, it is in the market. So, there is a huge market and it is a growing every year. And in occupational safety, as I have mentioned, that workers in agriculture. So, in agriculture they are always exposed in the sun, under the sun. Construction worker, so they are always working outside, so they are also exposed. Maritime sector requirement, so these people are exposed for long time, and they require durable high UPF textile. So, because they are this protective textile, their garments will be washed repeatedly, and that for that durable protective textiles, UV protective textiles are important, and also they are exposed directly under sun, and that is why we need high UPF textiles, and which is which meets the OSHA standard and or other different international standards. So, if we try to produce or develop any protective textile, this should match the international standards. So, material, different types of material innovations are there, like advanced nanoparticle incorporation. So, that if we incorporate the nanoparticle within the fiber, and that or maybe some nano particles coated textiles which will absorb UV ray and preventing it to which will block the UV ray and which will our body will be protected, and by proper fiber engineering. So, fiber cross sectional area, fiber type or different or fiber diameter, we can by changing the fiber cross sectional shape or by proper fiber engineering we can increase the ultraviolet protection. Functional finishes, different types of finishes, UV blocking finishes are there, which we can apply on fiber, even on the fabric. So, with superior UV blocking without compromising the textile properties. That means, this type of functional finishes which will not compromise the softness, handle, drape or comfort, moisture vapor transmission, so air transmission, that it should not block anything, but this type of material innovation is very important. So, all these factors drive the for development of UV protective textiles. Now, let us see that what are the ergonomic design principles in UV protective apparel. So, it is not that we are creating a fabric which is highly protected protective performance with, but at the same time the clothing apparel should be typically ergonomically designed. So, that is important, so that the person who is wearing, the body movement should not be restricted, and it should not affect the normal performance, it should be lightweight. So, all these things we should take into consideration. You can see the performance and protection balance is very important. So, we can have very thick fabric with very high protection, but at the same time if we increase the thickness, the bending rigidity or flexibility will be reduced, body movement will be restricted. So, we should optimize or we should balance all this. We should not compromise with the protection, at the same time we should not compromise with ergonomics, which will in fact affect the performance. So, effective UV protective clothing must integrate ergonomic considerations to ensure the user's compliance and functional performance. That is very important. Otherwise, the performance, if it is not that, if it is he is not feeling comfortable, then the compliance will, he may not use that protective textile. So, that means you cannot ensure the compliance, and the person will be at risk of the UV damage. So, what are this ergonomic or comfort related design? So, thermal management must be there. It should not actually prevent the body heat to come out, or body moisture vapor transmission should not, it should be breathable, and moisture wicking should be, it should have a good wicking property. It should have been it should be breathable, okay, despite tight weave. So, we need this tight weave for protection. So, we cannot have open structure, we cannot have open structure. If it is open structure, then UV ray can easily penetrate through the structure and our body will get affected. For that we need very tight weave woven fabric, so that it blocks the UV ray, very tight woven fabric we need. So, to block the UV ray, but at the same time if we block the UV ray by making the fabric tight, it should not affect the moisture wicking and breathability. It should not restrict the moisture vapor to get transmission to get transmitted through the clothing. So, that engineering we should do proper selection of fiber, by proper designing we can create this type of requirements. So, mechanical comfort must be there. We should not treat the fabric with certain coating which will reduce the flexibility, or it should not restrict the stretch property, or it should not have very rough structure surface. So, the mechanical comfort like fabric handle, flexibility, it should not also increase the shear stress. Shear properties are very important. If the shear resistance is increased, that means the body, our body with the movement of our body, the clothing will not be conformed, will not take the shape. So, that will then our body movement will be restricted. So, then it will create the discomfort. So, free body movement will not be there. So, flexibility, stretch recovery and low skin friction. So, these are the very important characteristics. If we create a fabric with high UPF, but at the same time low mechanical comfort or low thermal management capability, that means the performance, the compliance, the user compliance will be reduced, and he or she may not use this clothing. Anthropometric fit. So, we should create a certain pattern, that means the pattern should be such that it will cover our body with the maximum coverage will be there during the movement. So, that fit of the clothing in such a fashion that it should not restrict our body movement. At the same time, when our body moves, okay, that the pattern should be such that it should not expose our body to the sun. So, proper coverage should be there, and the apparel should be lightweight. That is very important. If the during the activity at high temperature, at the enhanced temperature, if the fabric weight or clothing weight is high, that means the performance will be reduced, functional performance will be affected. So, we should have a clothing which will be breathable, lightweight construction. So, our for the protection, UV protection, we can have very thick fabric, heavy fabric, that will give us very high protection. But our requirement is not the only the protection, we should have the performance. To have the better performance, we need a lightweight fabric. So, lightweight without compromising the UPF rating. So, lightweight construction is required, but at the same time it should be able to maintain the high UPF rating, ultraviolet protection rate. So, ultraviolet protection factor should be very high. So, poor ergonomics reduce wear time. So, we cannot wear the fabric for longer time, and the person at the outside, suppose he is working under the sun, and if the ergonomics is poor, in that case, so with the poor ergonomics, he or she will not wear the clothing for long time. So, may be removed. So, that will be that will affect the negatively the protection benefits. So, whatever protection benefits we are trying to achieve will not get. So, ergonomic of the apparel is very, very important. So, the design, whatever design we are doing, design means the anthropometric fit, mechanical comfort, thermal management, all this selection of fiber, selection of yarn, selection of coating material if at all it is there. So, selection of thread density, everything. So, all the design must address the thermoregulation, mobility and psychological comfort. So, that these are important. In addition to the prime requirement is the protection. Protection, that UPF should be high, at the same time we should have proper thermoregulation, proper mobility, proper comfort level. So, all these things we should although these requirements are just there is a opposite requirements, but we must balance. We cannot only try to increase the UPF with by compromising the other things. So, we should balance all these requirements. So, health implications of UV radiation. Let us see what are the different types of health implications. So, understanding the biological and dermatological consequence of UV exposure across diverse environmental and occupational context. So, that is very important. If we understand these consequences, then we can protect, we can actually develop our clothing. Now, we can see here. So, on our on the human health, so UV radiation is very important in our on our body to some for a particular type of UV radiation. So, it enhances actually the vitamin D sources, 90% of vitamin D sources we can get it from the sun, but at the same time this will affect our the human body. So, dermal synthesis via UVB radiation accounts for majority of vitamin D in human. So, UVB is the although it is harmful to some extent, but we need this UVB for vitamin D the generation in our body, and the optimal exposure with the minimum erythemal doses for adequate synthesis in temperate latitude. So, that is a 15 minutes the optimum exposure under sun which is required to develop the vitamin D in our body. The main clinical paradox is that balancing adequate vitamin D production against the photocarcinogenesis risk requires precise exposure guideline. That is important. We need the exposure for vitamin D, but the risk of skin cancer or different types of health hazard, it is also there at the same time. So, precise exposure guidelines are important. So, we cannot totally avoid the sun exposure, but if it is too long, that will affect the human body, and these guidelines are can be recommended by the physicians, and it depends on the location, latitude of the place, which season we are talking about, skin phototype, what type of photosensing effect is there on the skin, and at which time of the day. These are significantly influencing the synthesis efficiency. So, all these conditions, all these parameters we should keep in mind before we select the clothing. So, the occupational hazards and outdoor workers. So, the outdoor workers during their daily work, they may expose to UV, and there are different types of hazards are there. You can see the people working outside. So, workers in agricultural field, construction worker, maritime operators or landscaping faces chronic occupational UV exposure. So, which is exceeding 5 to 10 times recreational doses. Annually they get the 5 to 10 times actually that doses than the normal doses. So, these people agricultural, construction, maritime operators. So, these people they are always most of the time they are exposed to the sun. So, 5 to 10 times they are exposed. So, this the cumulative dose burdens are there. Now, outdoor workers, the agricultural workers, you can say 6,000 to 8,000 hours of exposure over 30 years career. Suppose a person outdoor workers, they are exposed, you can see that 30 times. So, 6,000 to 8,000 hours of exposure. So, for this type of work, outdoor workers, we must design a protective clothing with high UPF value. So, in 30 hours 30 years of career, so 6,000 to 8,000 hours he is exposed to the UV ray, and which dramatically elevates the skin cancer risk compared to indoor worker. So, the people needs protection who are working outside. Facial, dorsal, hand site or that this type of sites demonstrate the high tumor incidence. Different types of tumors can occur. So, there are some regulatory authorities are there. So, these frameworks are OSHA or NIOSH. NIOSH, OSHA and NIOSH recommends. They recommended that there are actually different types of PP regulation, and these administrative controls they are and they recommend the engineering solutions. What are the different types of engineering solutions are there, including the type of fabric and PP integration, different types of protective personal protective equipment integration it is required. So, Australia's Sun Smart program, because in Australia the sunburn or chances of skin cancer is severe due to their locational location, and also due to heavy sun exposure, and also some to some extent the ozone depletions are there, and they mandates a shade structure. So, they are mandating that workers should work under the shade. So, that is the one mandate, and then UV protective uniforms. So, they cannot work with a normal uniform, or they should the uniform should be UV protective, and the scheduled breaks during peak UV index. So, 10 am to 4 am. So, the workers who are working outside, so that is the break time 10 am to 4 pm, which is the highest UV index, that time UV exposure is there. So, that time the regulation is that they should not work within that time. So, one is the first is the mandate is they should work in a shade, Second is that they should wear proper UV protective uniform, and their working time is changed. So, before 10 am or after 4 pm, that is the working time. So, that to take care of their health, it has been, these are been mandated. Now, synergetic environmental UV risk. What are the different types of UV risk are there? Now, UV and heat combined risks. So, basically the problem is that when UV comes from the sun and it comes with the heat also, that combined risk is also enhanced, that enhance the exposure. Okay. So, that increases the different types of other problem. So, simultaneous UV and thermal stress, that is actually that exaggerates that the dehydration, that creates the problem of dehydration and reduce the cognitive function. So, if it is thermal stress is there, the people cannot perform their work in normally. So, their efficiency reduces and the chances of heat stroke is there. So, along with the UV, the heat always is associated with the UV. So, in addition to the UV exposure, so we are suppose we are facing all other risk. Okay. So, combined exposure impairs thermoregulation. So, and accelerated photoaging. So, person is exposed to UV and at the same time in hot places, thermoregulation it is that is get affected, and accelerated photoaging. So, that means at lower temperature the same with the same UV exposure, the type of photoaging will be there, that will be accelerated at the high temperature, which is through enhanced oxidative damage. So, oxidative damage takes place more, and it is getting the more effective at higher temperature. So, if the temperature is high, heat is more, so in that case the photoaging will be more. Next is that UV in marine environment. So, in marine environment the people are at the sea where salt water exposure is there. So, that will enhance the UV effect of UV. So, as we have already discussed that the water, it reflects the UV ray, it amplifies. So, water reflection amplifies the UV exposure by 25 to 30%. Whatever UV exposures are there, this a person the in the marine environment, the water reflects more UV and exposure is increased by 25 to 30%. So, that the person like surfers, sailors and marine biologists experience 50% greater UVB dose than their terrestrial counterpart. So, that is important. So, here you can see that they are getting 50% that marine, that 50% greater UV dose they are getting. And also in the seas, the salt water removes the sunscreen. If we wear the sunscreen and to protect us, so the salt water removes the sunscreen easily, and for that we need to apply the sunscreen very frequently. So, 40 to 60 minutes every 1 hour we have to replace the apply the sunscreen in the marine condition. So, we should have proper protective textile for the marine worker. And UV in desert environment. So, that in desert, as we have mentioned, that the sand reflects the UV 15 to 20%. So, there the main problem is that it is a low humidity in the because the moisture particle scatter the UV ray or it absorbs the UV ray to some extent, and minimal vegetation. So, here the vegetation is that, so like if there is a plantation, so that will also absorb the UV ray, but in desert condition humidity is low and vegetation is minimum. So, which increases the ground reflection. So, it from the sand the UV ray gets reflected easily, and sand reflects 15 to 20% of incident UV. So, that will enhance the UV radiation and which creates the multi-directional exposure. So, why is it multi-directional exposure? Because if you see the sand is not uniform. So, it gets reflected or scattered in different direction, and even the small sand particles, they will reflect in different. So, in different multi-directional exposure is there. Even if we are under the shade, okay, there also we get the reflection reflected UV ray. So, if we feel that we are not directly under the sun, so conventional sun protection strategy, it challenges. So, if we say under the umbrella or under the shadow we are doing, if we feel that with the conventional sun protection, so in that case will not be protected that much because of the multi-directional exposure. So, for all this condition, so a permanent solution is required. So, which is given by the protective UV protective textiles. So, this discussion will continue in the next session. Till then, thank you.